Okay, guys. Good morning. Good morning. Yes, I'm outside. Just double checking on this good weather, and it's real nice. I don't know what's going on, but my pen is. It's my computer that's moving slow. I need to shut it down. I'll do this video first. So let's come back to this real quick. Number 6 or 17. So we're going to solve this one several ways. You can actually plug them in. If they work out, then it works. But you have to plug it in for both. I just stick to the calculator, and I'm going to go here on a calculator screen. But you know what? I'm going to start the whole thing over again. Turn on new document. No, I do not want to save the stuff I was working on. I'll go to the calculator. I'm going to go to menu, 3, 2 equations. I'm going to type in there x plus 3y equals 5. And the next one over here, negative 2x plus y equals 4. Enter negative 1, 2, negative 1, 2. Pretty cool. Not too bad. So we're going to go with B for the first one. This one here, you do need to do a little work. It's really easy though. Remember the power raised to least. This is called a power. Anything with this power stuff, raised to a power. On your reference material, it will be there. Okay. So let me just show the work here. I figured out when it runs slow, it's just my computer that's slow. It's not the program. But you can multiply the power here, and the power here. So it becomes x to the 6, y squared, over z to the negative 2. Now, this is the issue right here. As far as everything's correct, we have positives, cool. We don't have to spike going up and down. This is an issue right here. You can't have a negative. So if you think about this, this is like a barrier. You want to throw it on the other side. Okay? Just on the bottom as a negative, it comes to the top as a positive. So if you look at it, this is all multiplication of fractions. And there's a 1 times this down here. So on the bottom, say it's 1. We'll keep x to the 6 on top. And y squared on top, which basically comes to this. Okay. So that's my answer. There she is. We should have a slope of 6 and a y-intercept of 3. Oh wow, that's super easy. That's a joke. I just saw it right here when I was reading it. Remember, it comes in the form of y equals mx plus b. M is your slope. B is your y-intercept. So if you look at your m, it's written by the x, check. 6 is there. And a y-intercept of 3, and my y-intercept of 3. Perfect. That was like a joke. It's just a good kind of, how do I say it? A good idea of what's going on, all right? Like it keeps, this is what algebra is. Understanding what they're saying in terms of x's and y's and stuff. It's not so much actually doing the work. A lot of the work you can do on a calculator, it's understanding the idea. Okay, this one says, what does that say? I'll give you a second or two to think about that one. What is that saying right there? This one's basically asking, you gotta understand what that says. F of 3, everything about f of 3, man, it's basically any f of x that's basically your y. And it's saying, hey, what's my y value when x is equal to 3? So they're saying, come down here where x is 3. X should be 3 around there-ish. So your answer will be between 7 and 10. Super easy question. Like, you got to realize what they're saying. I got to pause it, guys. Give it my charger. Yeah, so this next one is a joke. This is the way it always goes, you know. The meat market fight this costs. So these two go together. I won't lie. So you can start looking down already. I hit this, go with 5.99. See how this? No. Ooh. No. You see that? It's neither. And the chicken wings cost, and the chicken wings cost $2.29. I guess they're gonna go with K. What? F pounds of bacon and K chicken. Okay, that's kind of weird. So then let's see this one. Chicken pounds, right? Okay. So these two work. All right. Which equation can be used to determine the cost? This is kind of weird. It doesn't even tell you what's going on. But if anything, if you're going to buy both of them, okay. Which is not a solution. So I'm going to give you the idea, the heads up on this one. It's pretty easy. This one's basically saying like this. Y is greater than. So I want you to say it goes like that. It's shaded up here, okay? Yes, this should be dotted, okay? It won't be too bad. So you have a line coming through here that's dotted. It's a boundary. It's not included. The reason it's not included because the equal sign over here. There's no equal sign. And it's the shade above. So this is what's happening here. Not a solution. So they're going to give you 3 points that are over here on the solution side and one that's not. They're looking for this one, okay? So you can do it different ways. I don't really care how you do it. You can graph it. You can go ahead and, how do I say it, plug them in. You can do work, whatever. I'm just going to plug them in real fast. They're pretty easy. So I'm going to plug in 0 for the x and 4 for the y. So this one gives you 8 is greater than 6. Make sense? Check. That is true. The one that's not. This one here, we're going to get, what's that? 6, right? Is greater than -3 plus 6. Again, that's true. But we don't want that one. We're going to put in this one here. We'll get 10 is greater than 3 plus 6. That one's true. Now, there's some better work. Otherwise, I did everything wrong. 0 is greater than 6 plus, -6, right? Because -2 times that 3, -6 plus 6. That one is wrong, which makes this the answer. Pretty cool, right? That's how easy that is. Which expression can be used to represent the area? Okay. Every time we've done one of these guys so far, it's been, you will get this on the STAAR test. We've done perimeter. This one's area. Perimeter is not equal to area. Area is equal to multiplication of length times width. I don't care which is which, length and width, if you don't mind. So we're going to multiply those two. We're going to go with 8x minus 2 times x minus 1. Multiply this times this gives me 16x squared. Multiply this times this gives me a -8x. Then we multiply -2 times x, -2x, and then a -2 times a -1 plus 2. I want to argue this is the key thing to look at. Oh, my bad. This is a plus. So that this one times this one is a positive. This one times that one's a negative. My bad, guys. So look for this, look for this. Oh, they both have that. I'll say this one, these are out. Put these two together in the middle, gives you a -6x, and then -2, and 16x squared here. All right. Not too bad. It's actually very easy. Time out, guys, real quick. Okay, guys, based on the data in the table, which of these, which is the value of 5 in the linear? Value of 5 in the linear model. I don't know about that one. a value of, how about this, f of x when x is 5 or f of 5, something like that. So I'm going to say they're rooting for this 5 to be around here. Okay, so anything below, how about 140, anything above, ooh, man, that's crazy. Okay, so any more? What to do? I'm trying to do the easiest way. Well, there's several ways of doing it. I don't know how you want to do it. I can see from here to here, it grew twice, right? Since it's linear, I can do this. From here to here, come on, machine. It grew 108 minus 44, right? This becomes a 9er. 18, wait, I can do that one. Sorry about that. Becomes 64. So you can say for every move, right, it's going to be 32. So from here to 5, we're going to add, we can go, you can say plus 2, right? So we can add 32 and 32, or we can add 64. All right? Okay, so I used the calculator before. I'm going to show you this in the calculator again. So you don't have to think. You don't know what's going on. 044 to 108. I just don't like my pen right now. So 044 to 108. Menu 413. It is linear, so I'm going to go with linear. B, control this. Okay, so there's my, you can see M is 32, right? Like I showed you right now. So I just go control, add a page. I'm going to add a graph. I want to go up. I pressed up to go to it, okay? Here, I want to go to control T, and I go to 5. 5 is, alright, come on, pen. 5 is right here, and it's at 204. There it is, 204. Okay, for that one, 204. Come on, machine. Okay, which is not a fact about the line. Since they're talking about y-intercepts and slopes and stuff, what I'm going to do, I'm going to go y is equal to mx. You know what? I shouldn't write there. I'm going to put it in the form of y equals to mx plus b. So I'm going to solve this one for x. I'm sorry, for y. So I'm going to subtract x, and I wind up with a negative y is equal to a negative x plus 2. I don't like that negativeness, so I'm going to multiply the whole thing by a negative 1. I'm going to have y is equal to an x minus 2. Okay, so it has a y-intercept of a 2. Wrong. Oh, we're looking for the one that's not. All right, that's my answer. Okay, the slope of the equation is 1. Yeah, this is the 1x. Checked. That's true. We're not looking for that one, though. 3, 1 is a solution to the equation. I'll check on that right now. The graph is increasing. Make sure you know that if it's positive, then we should have a positive slope. If it's increasing, negative slope, decreasing, undefined, 0. So this is saying 3, 1. That's the only one I need to check. I know it's positive, so it's increasing. So I'm going to plug in, I guess I can do it right here. I'll put 1 as my y. You see, it's my y, and that's my x. Is equal to 3 minus 2. 1 is equal to 3 minus 2. 1. Check. So that is a solution. Slash, we don't want that one. We want the one that's not. So A is my answer. Oh my goodness. This one looks scary, but it's not. Okay. Make sure you understand what this one is doing or asking here. So I'm going to let you think about it real quick. What do y'all think? Okay, what this is asking here, that x is equal to half. So plug in right here, half for the x, and that's it. So you're going to have 4 plus 6 times a half. Everybody knows what's half of 6 over 2. 4 plus 3 over 2. 7 over 2, also known as 3.5. And there she is. Easy cheesy.